Topic 3.5, dividing whole numbers and fractions. When you first studied division, you learned two ways, sharing and grouping. For example, 20 divided by 5 can be thought of as sharing 20 items equally among 5 sets with 4 items in each set. Or grouping 20 items into sets of 5 with 4 items in each set. Recall that multiplication and division are inverse operations. That is, they undo each other. If we know that 20 divided by 5 is equal to 4, what related multiplication facts do you know? Well, we know that 4 times 5 will equal 20. And we also know that 5 times 4 equals 20. Now, when we're asked to divide a whole number by a fraction, we can use a number line. You can make a number line that goes to 6 and take each one of these 6 and divide it into its thirds. Okay? And then just count how many thirds there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 thirds in 6 wholes. Now, you might have discovered a shortcut while I was going over that. If you know that there are 3 thirds in every one whole, then you can simply take the number 6 and multiply it by 3. Okay? That method is one where you use what is called the reciprocal of 1/3, which is its complete opposite. So, in other words, you just flip those two values. And then what you can do is you can just multiply straight across. 6 times 3 is 18. Okay, remember that when we have a whole number, it's actually over 1. 1 times 1 is 1. And our answer is 18. We can also show that same problem using fraction circles. So what we want to do is divide each of these fraction circles into 3, into thirds, right? And then you count how many thirds there are in the 6. So we've got, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's try a few more examples. 5 divided by 3/4. We could do this using a number line. We could do this using fraction circles. I'm going to show you the fraction circle method. So I'm drawing 5 circles. I'm dividing them into quarters. Okay? And now I'm interested in knowing how many 3/4 there are in the number 5. So I'm just going to start numbering them. 1, 1, and 1. This is the first set of 3/4 in 5. So now I'm going to go and do the second set. Second set of 3/4, actually, I put 1 extra there. That's the second set of 3/4. Here's the third. Here's the fourth. Here's the fifth. Here's the sixth. And here's the 7th. Okay, so we have 6 whole sets of 3/4, And then we have 2 out of 3 quarters. So that means that this would be 2/3, because 3 is how many we need to make a complete set of 3 quarters. Now, we could have solved that same problem using the reciprocal method. So what we're going to do when we use that method is we'll put our whole number over 1, always. And then we're going to flip the second fraction here. We're going to take this second fraction and we're going to flip it. We're going to use its reciprocal. So we're going to put 5 over 1, and we're going to put the reciprocal of 3 quarters, which is 4/3. And then we're going to actually multiply rather than divide. Okay? 5 times 4 is equal to 20. 1 times 3 is equal to 3. 20 over 3 converted into a mixed number is 6 2/3. 3 goes into 20 6 whole times to get to 18, and then there are 2 left over to get to 20. 2/3 left over. So 6 2/3. So this is the alternative method we'll use for the last 2 examples. How about 9 divided by 3 quarters? What we can do is we can put 9 over 1, and we can use the reciprocal of 3 quarters, and then just multiply straight across. This process is also known as cross multiplying. You may have heard of it called that. That's basically what we are doing. So we're cross multiplying. We're taking 9 over 1, we're going to multiply, and what we're going to do is multiply by the reciprocal of 3 quarters. In other words, we're multiplying this way. These 2 lines cross, and that's why it's called cross multiplying. So 9 times 4 is 36. 1 times 3 is 3. 36 divided by 3 is 12. And how about the last one? 5/8 divided by 2. Well, we can follow the same procedure, only this time the whole number is on the right. So we'll put the whole number over 1, and then we'll use the reciprocal of this fraction, which is just these 2 numbers flipped. So it would be 5/8 times 1 over 2, which would give us 5 over 16. It looks like these 2 numbers, there are no common factors other than 1, so this is already simplified.